1 plus R. By the time I get here, this 9 rupees is discounted by 1 plus R to the power 6, right? So the effective cash flow that I get, or the present value of cash flow that I get, is just this bit. Actually, this 109 gets discounted by 1 plus R to the power 8. So that means, effectively, this is the present value of the cash flow that I'm getting, although I'm getting 109 rupees. That cash flow is only worth this much in present value terms. Okay. So I look at, okay, in present value terms, what is the percentage of this cash flow? So if this cash flow, let's say, for example, is 40% of the cash flow I'm supposed to receive in present value terms. This cash flow is, let's say, 90% of the cash flow I'm supposed to receive in present value terms. So 90% of 9 rupees. This is 40% of 109 rupees. This is, let's say, 92% of a 9 rupees. Okay. In present value terms, what is the weight of the cash flow per price? Okay, actually, it's, sorry, that is my mistake. I'm sorry about that. It's not 40% of 109 rupees as a percentage of the price of the bond. Sorry about that. That is my mistake. So the price of the bond means 90%. Would be 90% of the price. What is the price of the bond? The price of the bond is the addition of all of these present value of cash flows, right? Price of the bond is the addition of all the present value of your future cash flows. Okay, that's the price of the bond. So per price of the bond, what is each present value of each future cash flow? That's the weight. And then you multiply it by the time, and this is the weighted average time. Weighted average time. That's what we call Macaulay duration. Weighted average time of a bond. Okay. Let's just do a quick example. And we'll work it out through the example. Try this first example. So Macaulay duration is time into the weight. Weight of what? Present value of each cash flow divided by the addition of all the present value of your future cash flows, which is your price. So I wanted to work out the sum, but an easy way to work out the sum is to put your data into your, so look at what is the time, what is, what do you call it, with each cash flow, what is the present value of each cash flow, what is the weight of each present value, and then time into weight. To come up with the addition of that, right? The addition of time into weight is the duration, Macaulay duration of the bond. Send your answers on chat, please. If there are questions, let me know. Questions? So let me work out the first sum with you. 3-year bond, right? 3-year means you have 3 cash flows. What are the cash flows? You have annual coupons, so 3 coupons. Each coupon is 18%. Assuming what? Face value is 100. We always assume face value is 100 unless otherwise given. So how much is your coupon? 18 rupees. And at the end of the period, end of the 3 years, you get back the 100 plus the 18 rupees. This is where you are today. So when I fill up my table, what is T? 1, 2, 3 years. Right? T is in years. And then cash flows are what? Cash flows are 18 rupees, 18 rupees, and 118 rupees. What are my present value of cash flows? 18 rupees should be discounted not by the number of years, by the number of periods. Here, the years and the number of periods are the same because it's annual coupons, right? So what is N? The number of periods. It is the same because it's annual coupons. If it was not annual coupons, it would be different. Okay. So 18 divided by, what is the yield to maturity? 30%. 1 plus 30%, 1.3 to the power 1. 18 divided by 1.3 to the power 2. And 118 divided by 1.3 to the power 3. Can somebody tell me what these numbers are, please? Okay, Niraj, duration looks correct. 59. Is that 118 divided by 1.3? What is 18 divided by 1.3 to the power 1? Thank you. 13.8461. Okay. And then 10.6508. Okay. Oops. And 118 is 53.7096. Okay, thank you. So when you add this up, you get the addition of all the present values, and you should understand the addition of all the present value is equal to the price. This is something that you know. When you add up all the present values, that is equal to the price of the bond. So how much is the price of the bond? Okay, 78.2065. Right. Now I have the price of the bond and I have the present value of each of these cash flows, right? Now I need to find what is the weight. What is the weight of each of these cash flows as percentage of the price? So 13 as a percentage of 78, 10 as a percentage of 78, 53 as a percentage of 78.2065. What is the weight of each of these cash flows? Okay. 13.846 divided by 78.2065, I'm being told is 17.70%. 10.65 divided by 78.2065 is 13.61%. If any mistakes are there, please point it out. Thank you very much for giving me the numbers. But if anybody else is getting different values or there is a mistake, please point it out. And 53.7096 divided by 78.2065 is 68.67%. Okay. So what does this mean? That means 68% of the cash flows occur in year 3, which makes sense, right? Because you're getting your face value in year 3. 68% of your cash flows occur in year 3 in present value terms. 118 divided by the total cash flow is different. We are looking at present value terms. Now, what's the last step? You have to multiply or each of these cash flows by the time. So 17.7% multiplied by 1 year. 13.61 cash flow occurs in year 2. So I'm finding the weighted average time. 68% of your cash flows occur in year 3. So T1 multiplied by W1, 0.1770 multiplied by 1. That is still 0.1770. Right. 13.61% multiplied by 2, which comes to how much? 0.2722. Correct? If I'm wrong, please let me know. 0.6867 multiplied by 3. How much is that? 1 point or 2 point? Waiting for the answer. 2.06. Okay. Thank you. 0601. Okay. Now I have the time multiplied by W. This is not the final answer because what is the final answer? I have to add it up. When I add up T multiplied by W, I get the final answer to be 2 point, how much is it? 45093. Six zero nine three. Is it 6093 or 5093? 5093. Okay. Okay. What does this? Thank you. What does this mean? 2.5093. We are not coming to the final meaning yet. Okay. But we are seeing that although this is a 3-year bond, when you look at the present value of cash flows, this is like a 2.5-year bond. This is like a 2.5-year bond where I get all my cash flows at the end of the period. So this 3-year bond where I get cash flows of 18 rupees for the next 3 years, we are saying is equivalent to, right? Equivalent to a single bond where you get cash flows in 2.5093 years, right? 2.5093 years, where you get one single bulk cash flow in 2.5093 years. This is what your Macaulay duration tells you. Okay. So this is equal to a 2.5093 year zero coupon bond. And you see why that is in a minute. So again, this bond, when I take the present value of cash flows, is actually not a 3-year bond. When I take the present value of cash flows, it is equivalent to a 2.5093 year zero coupon bond. Okay. That's what it's saying. So right. Let's do. Can you do question number 5? Try question number 5. Remember, Macaulay duration is given in years. So this is 2.5093 years. All durations are not given in years. Some are just Urix, but Macaulay duration is in years. Right, question number 5. Right, correct. Just yes, correct. 'It's actually very easy. Others, that's the easiest question actually of the 5. Um, 57, no. So always face value is 100, right? Niraj, yes. Sampath, yes. Right. So now you see this is a zero coupon bond, right? 3 year zero coupon bond, yield to maturity 30. So yield to maturity still remains, yes, Divankar, still remains at 30. Yield to maturity has not changed here. But now what has happened? Coupon has gone from 18 to 0. It's still a 3 year bond. Okay. What do you say? What are your cash flows? If it's a zero coupon bond, no cash flows in between. In the third year, you get back your face value of 100. That's it. That's all your cash flows, right? So what are your cash flows? 0 in the first year, 0 in the second year, and in the third year, you get back 100. So what is the present value of your cash flow? This is 0. This is 0. This is 100 discounted at 30% for 3 years. How much is that, please? 100 discounted at 30% for 3 years? 45.5166. Okay. Right. So that means your price is simply 45.5166. So what is your weight? 0, 0, 100% of your cash flows occur in year 3. So therefore, what is T into W? 0 into 1, 0 into 2, 100% into 3. Add it up. It's 3 years. So what do you see? Always in a zero coupon bond, the life of the bond equals the duration, the Macaulay duration of the bond, right? Always in a zero coupon, you don't have to do any calculations. Always in a zero coupon bond, the life of the bond equals the Macaulay duration of the bond. So that's why you all got 3 years through calculation. We don't need to do any calculation. Zero coupon bond. That's why earlier also I showed you it's equivalent to a zero coupon bond, right? So therefore, what is, if I have a zero coupon bond that pays me cash in 3 years' time, this is equivalent to, duration is equivalent to a zero coupon bond that pays me cash in 3 years' time. This is a zero coupon bond, right? So let's look at the other. One second. This is what we have. This is what we just did, right? So I have N what do we say, T, your cash flows, then your present value of your cash flows, then okay, present value of cash flows, and then P, sorry, the weight, and then P into the weight, right? This is what we need. So what is N? It's a 3-year bond. Let's do it for the first one. So for the first one, we have a 3-year bond. T is also 3 years. And then T, there's no difference between N and T because the number of periods equals the number of years, right? What are my cash flows? What are my cash flows? I got 18 rupees, 18 rupees, and 118 rupees. What was the present value of cash flows? 18 rupees divided by 1 plus 30%. 1 plus 30%. To the power n. So this is what you all got now. 13.8462, 10.6509, and 53.7096. And this was price, right? This was equals to the price. And then what did we do? We looked at the percentage, right? So this is also what you all got. 17.7%, 13.61%, and 68.67%. And then what did we do? We multiplied that by time. So we multiplied by time and added it up, and we got 2.50972. That was for the first one, correct? So this is the answer for the first sum that we did. So same way, we can do it for the second sum. Make some adjustments. What is the second sum? It says, oh, the first one hasn't got copied, right? 3-year bond, coupons of 8%, 30%. So what is the coupon rate here? This is 8%. Here the coupon rate was 18%, correct? So what are my cash flows? 8, 8, 10, 108. Is that okay? My cash flows are 8, 8, 10, 108. This didn't change. Only thing is I have to move this. So what is the difference here? You see, duration for the first part, for the first sum is 18%. Three-year bond, that's the first one. For the second sum, it's 2.7. Why did the duration change? The yield did not change. What changed? The coupon. Coupon changed. And what happened to duration? Coupon went from 18% to 8%. What happened to duration? It went from 2.5 to 2.7. What do you see? When the coupon rate came down, when the coupon rate is lower, it's not that the coupon rate can come down, but when the coupon rate is lower, duration of a bond is higher. When the coupon rate is lower, duration of a bond is higher. What does the third one say? Third one says 3-year bond, coupons of 18%, yield to maturity is 15%. Now, compared to the first one, 18%, yield to maturity 30%, right? 18 and 30. Second one, we changed the coupon. Third one, we're changing the yield to maturity. I hope you all can see. Is that enough for you all to see? You all can't see, just let me know. Thanks. So now it's still 18% coupon, but now yield to maturity is 15%. So change this. Okay. What do you see? This becomes 2.5796. Okay. From 2.5. Now, what again has happened? Coupon is 15%. Sorry, yield to maturity is 15%. Here, yield to maturity is 30% in the first sum. Now, what has happened? Everything remaining the same. Life is the same, right? What has changed? Yield to maturity has changed. And what has happened? Yield to maturity has come down. Interest rates have come down. And what do you see? From 2.5, your bond's duration has gone up to 2.57. Okay. So duration is inversely related to yield to maturity. It is inversely related to coupon. Okay. So again, duration is inversely related to coupon because duration goes from 2.5 to 2.7 when coupon rate drops from 18% to 8%. Okay. But same way, when yield to maturity drops from 30% to 15%, what do you see? Duration goes from 2.5 to 2.57. That means duration increases when yield to maturity comes down. Duration and yield are inversely related. Okay. So, fourth one. Fourth one, what does it look like? Look at a 2-year bond. 18% coupon, 30% yield. These don't change, but what changes? It is now a 2-year bond. Right? It is a 2-year bond. In a 2-year bond, now I don't have, it's only a 2-year bond. So what are my cash flows? 18% coupon, annual coupon, 2 years. So in the first year, I get 18 rupees. In the second year, I get 118 rupees. Is it right to compare duration of bonds with two different years? No. So what we're trying to say here is, Tivanka, that the bonds, we're not comparing the two bonds. What we're saying here is that when the duration, for duration, your yields, when yields and duration are inversely related. That's it. That's what we're trying to show. Yields and duration are inversely related, leaving everything else the same. Life is the same, coupon is the same. When yields change, duration changes, and it changes on an inverse relationship. So, 2-year bond. What do you see? 30% coupon. Here, of course, it won't change, but just for completeness sake, let me just put that there. Okay. What do you see here? What has changed? Life, right? 3-year bond now is a 2-year bond. What do you see? 18% coupon, 18% coupon, 30% yield, 30% yield. What has changed? Life. My duration is 2.5 for a 3-year bond. My duration is 1.8 for a 2-year bond. So lower the life, lower the duration. Higher the life, higher the duration. 2-year bond has a 1.8 duration. 3-year bond has a 2.5 duration, right? So life of the bond and duration or maturity, life or maturity of the bond and duration are proportionately relational. Okay. They're not inversely relational. They increase on a proportionate basis. They're proportionately relational, right? So again, what do you see? Coupon and duration are inversely related. Yield and duration are inversely related. Life or maturity and duration are not inversely related, they are proportionately related. Yeah. And the last part, we did it, but just for completeness sake, let's do it. So it's my zero coupon bond. Right, you can see it here. So zero coupon bond. I get 100 at the end of the period. 3-year coupon. Zero coupon, yield to maturity, 30%. So zero coupon, yield to maturity, 30%. Right. 1. And therefore, duration is 3. Okay. Now, that's the fixed one. Okay. Now, what do you see? That's the last point. Duration increases with maturity of the bond, but the maximum duration you can have is the life of the bond. Always the maximum duration you can have is the life of the bond, right? Macaulay duration. So always the maximum duration you have will be the life of the bond and duration. Otherwise, your calculations are wrong. If you get a duration greater than the life of the bond, that means your calculations are incorrect. Okay. So what is the maximum duration you can have? Life. How do you get the maximum duration when coupon rate is 0? Zero coupon bonds will always have a duration equal to the maturity or life of the bond. And that is the maximum duration you will have. So what are the points we're seeing here again? Maximum duration you can have is equal to the life of the bond, which will occur when the coupon rate is 0, right? When coupon rate comes down from 18 to 8 to 0, what do you see? Duration goes up from 2.5 to 2.7 to 3. 3 is the life of the bond because coupon rate is 0. Then it doesn't matter whether yield is 30% or 15%, or you keep an eye on this, right? Keep an eye on the duration. Yield is 30%, 15%, 10%, 2%, it doesn't matter. If your coupon rate is 0, if it's a zero coupon bond, duration is always equal to the life of the bond. Is always equal to the life of the bond. And that is the maximum Macaulay duration you will have. All of these durations are given in number of years. Okay. So, any questions here? So we move back. And that's why it says duration is equal to maturity for zero coupon bonds. Duration is shorter than the maturity for all bonds except for your zero coupon bonds. Okay. So that's why we saw this bond had a duration of 2.5. This bond had a duration of 2.7. 2.57 and 2-year bond was 1.8 and 3-year bond was 3. What do you see? In the first bond, 3-year bond, 18%, 30. From this, what is different? 3-year bond, 8%, right? Therefore, what do you see? Coupon rate came down, right? Coupon rate came down, duration went up. In this bond, what was different from the first bond? 30% versus 15%. What happened? Yield came down, duration went up. Okay. This bond, what was different? The 3-year, it's a 2-year bond, not a 3-year bond. So what do you see? Maturity came down, call it T. Maturity came down, duration came down, right? And here, coupon rate came down to 0. So duration went up to maximum duration, right? Which is the life of the bond. So what do you see? Coupon rate and duration are inversely related. Duration and yield to maturity are inversely related. Duration and life are proportionately related. The maximum duration that you can have is equals to the life of the bond, always. And this is when the coupon rate is equal to 0. Oh no, you can only see the Excel sheet. Only now you all are telling me you can only see the Excel sheet. I'm writing like crazy here. Sorry. I've done all this writing and you missed all of that, right? So this is what I was saying. Okay. Coupon rate decreases, duration increases. Here, yield decreases, duration increases. Here, time decreases, duration decreases. And in the fifth one, coupon rate comes down to 0. So duration goes up to the maximum duration, which is the life of the bond. So duration and coupon rate are inversely related. Duration and maturity are inversely related. Duration and life are proportionally related. And the maximum duration is equal to the maturity or life of the bond, which occurs when coupon rate is equals to 0. Questions? Okay. Now we move on. So we use this concept, right? But to use this concept, we had to make a slight modification. So really what we want to now figure out is how does this impact price? Because we're talking about interest rate sensitivity and how the change in interest rate impact price and by how much. So to use Macaulay duration, we can't use Macaulay duration as is to calculate interest rate sensitivity. We have to make a slight modification to it, which is why we come to the concept of modified duration. Modified duration is simply Macaulay duration, right? Macaulay duration divided by 1 plus the yield for the period. Yield for the period, right? So this is what we call modified duration. And modified duration actually helps us a lot in terms of figuring out interest rate sensitivity, because we use the concept of what we found here. All these findings, the fact that duration is inversely related to coupon rate, inversely related to yield to maturity, proportionately related to maturity, right? We use all of that, we modify it slightly, come to modified duration, and we use modified duration to look at interest rate sensitivity, because we say the percentage change in price of a bond. The percentage change in the price of a bond. What is that? That is when interest rates change, bond prices change, right? So if today interest rates are, let's say, 12% and bond price is a certain price, when interest rate changes from 12% to, let's say, 11%, bond price changes from P1 to P2. So the percentage change in price, what is that? P2 minus P1 divided by P1. Is equal to minus modified duration into the change in interest rate. Into the change in interest rate. Okay. Minus modified duration into the change in interest rate. Percentage change in a bond's price is actually not equal to, we say it is approximately equal to, because there is a problem here. It is approximately equal to. Why the minus? The minus is there because bond prices and interest rates are inversely related. So when interest rates go up by 1%, percentage change in price is negative. When interest rates come down by 1%, percentage change in price is positive. To reflect that, this equation says it's minus, right? Percentage change in price is approximately equal to negative modified duration into the change in how much interest rates change. And this equation, we say, holds true as long as interest rate changes are very small. For very small changes in interest rates, this equation is approximately true. Let's try it. Let's see. Let's test whether this is true or not, right? So use the information that we did earlier. What is the price of a 3-year bond, 30% yield, annual coupon of 18% if interest rates fell by 1%, right? So yield to maturity goes from 30% to 29%. Calculate the price of the bond based on modified duration and based on actual present value of future cash flows. If interest rates fell by 1% to 29%, how much is the price of the bond based on actual discounting of present value of future cash flows? Or do the same sum based on modified duration. How do we do it based on modified duration? You already have the Macaulay duration. We already have it. We've done the sum. Okay. Use that information to calculate P2. For the first part, use that information to calculate P2. Yeah. How much? It's actually very easy. It shouldn't take this long. What is the modified duration? Tell me what is the modified duration? You have a 3-year bond, 18% coupon rate, yield to maturity 30. So what is the duration of the bond? Macaulay duration? What is the Macaulay duration of the bond? No, it's not 59. That's not correct. But is this the modified duration or the Macaulay duration? Modified or Macaulay? Uh, 55? That's also not correct, right? Again, it's the, I believe the modified duration is not correct. The Macaulay duration is not correct. So first, just reset. What is the Macaulay duration of this bond? What is the Macaulay duration?
3 years.
It's not 3 years. It's 3 years if it's zero coupon. But it is not zero coupon, it's an 18% coupon bond. Janani, correct. What is the Macaulay duration of this bond? Sorry, Janani, not Janani, 59, correct. Janani, no. We just did that, right? That's this calculation. 3-year bond, 18% annual, 30% yield to maturity. 3-year bond, 18% annual coupon, 30% yield to maturity. So the Macaulay duration of this bond, we calculated already. You all don't need to calculate it. The Macaulay duration of this bond was 2.5093. Right? We just calculated it here. 2.5093. What is the confusion here? No, you're not supposed to do it for 29. You're supposed to do it for current yield to maturity 30. And then use that to calculate the percentage change in price. You're supposed to do it. What we're trying to do is to say, right now, today, at this moment, interest rates are 30%. In this example, interest rates are 30%. So I have a bond that has a duration of 2.5093. If interest rates come down by 1%, what will happen to the price of the bond? So then you don't recalculate duration. You use the duration at current interest rates and use that to calculate what will happen to the price of the bond. Okay. Otherwise, you've already calculated the price of the bond at 29%. If you try to do 29%, you already calculated the price of the bond, right? Because by the time you do the addition of all the present value of future cash flows, you already got the answer. So we use current duration to estimate what the price is going to be. So Macaulay duration right now, when yield is 30%, is 2.5093. Okay. What is the modified duration? Modified duration is, what do? We take the Macaulay duration and divide it by 1 plus yield for the period. What is the yield? 30%. Period is annual. So yield for the period is 30%. Right? At 30%, because currently interest rates are 30%. Right? This duration was calculated for 30%. So you divide it by 30%, right? Y is 30%. So 2.5093 divided by 1 plus 30%. So how much is that? 1.9302. Okay. Now, what does this say? This modified duration says for every 1% change in interest rates, for every 1% change in interest rates, my bond changes by 1.9302%. This is what my modified duration tells me. For every 1% change in interest rates, my bond changes by 1.9302. Okay. If interest rates go up by 1%, my bond price will come down by 1.93%. If interest rates come down by 1%, my bond price will go up by 1.93%. This is the duration concept. It's not completely accurate. It's an approximation. It is accurate for small changes in interest rates. For large changes, actually, this creates an error. That's what we're trying to show, right? But this is a very quick calculation. When I know my duration, because I can find it through Excel, right? Duration is available. You can do a quick calculation and find duration. In Excel, for example, you put the modified duration equation, you can find modified duration. Once you know your duration, it's very easy to figure out, okay, if my duration is 1.93, it means approximately for every 1% change in interest rates, for every 1% change in interest rates, price changes by this much, by the amount of my modified duration. But this is not a perfectly accurate depiction. It is an estimate. Okay. But according to the estimate, for 1.9302, right? My modified duration is 1.9302. And it's saying, now the question is asking, if interest rates come down by 1%, what is the price? What is the new price of my bond? Okay. So the equation says, according to the equation, the percentage change in price of a bond, the percentage change in price of a bond right, which is what? P2 minus P1 divided by P1 is equals to minus modified duration into how much interest rates change by. Okay. So now I'm saying interest rates are coming down by, this is why, so 1 second. This is why we say for a 1% change in interest rates, right? Do you see this equation changes to percentage change in price of a bond is equals to the duration of a bond. The modified duration of the bond. For a 1% change in interest rates, when the change is 1%, this is equals to the duration of a bond, right? That's why I can look at this. I can look at my duration and quickly say, is this bond sensitive to interest rate changes or not? I know as soon as I look at my duration, okay, this bond is a bond that is 1.9 times sensitive to interest rate changes. When interest rates change by 1%, I can expect my bond prices to change by 1.9%. Okay. Now, interest rates are coming down by 1%. Interest rates are coming down by 1%. So, what is the impact to my bond? The impact to my bond is when interest rates come down by 1%, my bond percentage change in price will go up by 1.9302%. It will increase by 1.9302%. So P2 minus P1 divided by P1 is equals to 1.9302%. You know P1. We calculated it earlier. How much was it? When we did our first sum, P1, not the duration, P1. What was the price when yield to maturity is 30% for an 18% coupon bond? What is the price? You are already calculated this, right? We already know the price. How much is it? $78.2065. Okay. So using this, I can approximate. I know when interest rates come down by 1%, my price is going to increase by 1.93%. So P2 minus 78.2065 divided by 78.2065 is approximately equal to 1.93. So the price is approximately equal to how much? Okay, 72.7476. Can somebody confirm? Thank you. So 72.7476. That's the price of that should be approximately the price of my bond when interest rates come down by 1%. Can you all check that? That's the second part. Second part says check it. Can you check it, please? How do you check it? Do it through fundamentals. You have a 3-year bond. Right? You have 18. You can do it through the equation or whichever way. But do it through fundamentals. What is the price of this bond when yield to maturity is 29%? Why 29%? Because we know when yield to maturity is 30%, price is 78.2065. We use that to figure out when yield to maturity is 29%. That means when interest rates come down by 1%, price should be 72.74 to 76. Can you check through fundamentals whether this is correct or wrong? What is the price? Okay, sorry about that. Obviously, this is wrong, right? Now I asked you all to double check and somebody reconfirm, and you all said that was correct. But this is not correct? Is everybody getting this answer? If you're getting this answer, this is not correct. Yeah, because you see, this is plus. Your interest rates have come down, so your price should be higher than 78.2065. How does it become 72.7476? Okay. So how much should it be? 79.7160. Is that correct? You all have forgotten to participate. We were out for 3 weeks and you all have forgotten how to participate in conversations. What has happened? 79.7160. Is this correct? Can somebody else also please confirm? 79.716. Okay, thank you. So here, when we do it through basics, what do we get? At 29%, what should be the price? I can do it through the equation as well, but because this only has 3 cash flows, I'm just going to do it through basics. 18 divided by 1.29 plus 18 divided by 1.29 squared. It's only because it has only 3 cash flows, right? Otherwise, we'll use the equation. Plus 118 divided by 1.29 cube. And you all are getting 79.7385. Is that correct? Multiple answers. What's the final answer? 7385. Is that correct? Seven three eight five. Okay. 79.7385. Okay. Do you see it's very close? I hope this is correct. I don't trust you all anymore now. Okay. 79.7385. Do you see that this is very close? It's not the same though. That's why we say it's an approximation. It is not the same, but it is very close, right? 79.7160 at 29%. So I'm using the price at 30%. I know already the price of this bond is 78.2065. I'm using that. I'm using the fact that the duration is 1.9302 to approximate that the price is going to go up to 79.7160 or go up by 1.93%. When I check the actual price is 79.7385. It's different, but it's very close. So for small deviations, right, 1% small amounts, these two prices will always be very close to each other. So 79.7160 and 79.7385. Right. So this is 79.7160. And this is 79.7385. Very close to each other. So what's the reason for the difference? The reason for the difference comes because of the convexity of the bond. Okay. So we know that bond prices and yields are inversely related, right? So when I draw my price versus yield, what is duration? Duration is the slope at any point in time. In this graph, the slope at any point in time. Let's say here. Let's say this is the point where your yield is 30%. And your price is, how much is that? Sorry, how much is price at 30%? 79.2065, is it? Please correct me if I'm wrong.
Yes, madam.
Yes, madam.
Thank you. 78.2065. Right. Okay. So when interest rates come down from 30%, I'll just take a big jump. When it comes down from 30% to 29%, actually, you see that the price should be this, right? It should be 79.7385. Duration looks at the slope of my curve, right? So it looks at the slope of my curve at 30, and it says that this slope is going to continue. The straight line is going to continue, right? And it approximates the price here. So I'm using big changes just to show you, but you should see that for small changes in interest rates, this error is very small, right? I'm using a big jump. I'm magnifying it to show you where the error is, right? But you can see here when you take the slope, depending on the convexity, depending on the curvature of this, because this is not a very nice curve, I have drawn this, right? Depending on the curvature of this bond and the slope where it falls, you can see that the error is very small for small changes in interest rates, right? For larger changes in interest rates, the error becomes larger. But I'm magnifying this effect just to show you what we got. This is what we got, right? When we did the duration approximation, we got the price to be 79.716. Because duration assumed that that straight line will continue. And based on that straight line, it said when interest rates come down by 1%, your bond will go up by 1.93, no? 1.93%. So it assumed for small changes in interest rates, it was accurate to look at a straight line increase. Okay. And that's that error. This is the error. But that error is very small when we look at small changes in interest rates. So duration gives me a quick way to evaluate what are the good bonds to buy. Yeah. But duration has problems, as you can see. Yeah. Here, you can see when interest rates come down by 1%. Do you see when interest rates come down, the duration estimate underestimates the price. Okay? It underestimates the price. Do you understand what I mean? It underestimates the price because you can see actual price should be 79.73, but duration says price is going to be 79.71. So the duration approximation underestimates the price when interest rates come down. It also underestimates the increase in price. It's two different things. Increase in prices, duration says the price will increase by 1.93%. But actually, you can see the price has increased by a little more than 1.93%, right? So the increase in price also, it underestimates. See what happens when interest rates go up? When interest rates go up, right? Let's say interest rates go up from 30 to 31. Let's look at this corner of the room, right? So when the interest rates go up from 30 to 31, this is where the price should be, okay? When I magnify it and show it, this is where the price should be. Okay. duration approximation says, this is where the price will be. P3 dash for duration, okay? P3 according to duration. It says this is where the price will be. So do you see, because duration says the price will come down by, when interest rates increase, duration says the price will come down by 1.93%. Right, 1.93%. Here it said price will go up by 1.93%. Here it says price will come down by 1.93%. But we see that actual price is here. So this is the error. That's the error. So when interest rates go up, do you see that duration still underestimates the price? I just put some false figures here, right? When interest rates come down, let's say the actual price should be 77. Let's say the duration approximates it to 76. These are false prices. Don't depend on them, right? Duration underestimates the price. But do you see it overestimates the decline in price? Right? Here it underestimates the increase in price, it overestimates the decline in price. It says price is going to decline by 1.93%, but price doesn't decline as much. That's because of the curvature of the graph, the convexity of the graph. So when interest rates come down, the curve is steeper, right? So duration underestimates that increase. But that's okay, because we're going to get a better increase than that. Okay. It gives me a sense of my risk. When interest rates go up, because the curve is like this, it actually overestimates the decline in price. That's also okay. Because from a risk perspective, I'm thinking, okay, this is going to come down by 1.93%. Actually, it won't come down as much. It will come down by a little less for smaller changes in interest rates. Okay. So duration, when I look at duration, it gives me an idea of the sensitivity of my bond. There is an error, but this error is small for small changes in interest rates. It is a good way for me to check which bonds I should buy when I'm looking at, okay, what are the ideal bonds for me to buy? Duration will give me a really good way for me to check which bonds I should buy, because it shows me the sensitivity of the bond to interest rate changes. Of course, the sensitivity to interest rate changes, it's inaccurate, but close enough for small changes in interest rates. Questions? Okay, so let me show you something before we stop. Unfortunately, we have one more sum, but let me just show you. Okay. A second.
Excuse me, Miss. What do you use this for?
Duration. Duration you use to actually figure out which bonds to buy. That's what I'm going to show you now. Just give me one second. So when I want to figure out, okay, what's a good bond to buy? Ideally, I would look at the duration of the bonds to choose which bonds are more sensitive, because when I think interest rates are going to come down, I would want to buy the bond that is better sensitive to interest rate changes than the other bond, right? Versus when interest rates are going to go up, I would want to buy bonds that are less sensitive to interest rate changes. that, and then vice versa. So let's see how we can do that.
So meaning you look at the modified duration.
Modified duration. Yes, you look at the modified duration. So I'm on the central bank website. We go to, I'll just, the same daily report that you use in your assignment, daily summary report, right? And so you have your key bond codes. Right. Hope we have enough time to do this. Let's see. Otherwise, next week I'll show this to you again. Okay. So you have the selling price and the buying price, right? You have the yield. We have the coupon rates. We have today's date. Um, I'll just use the average yield. It doesn't matter. Sorry. So you have the coupon rate. So you can find the duration, right? So you can say, let's just use, you have the M duration formula as well. That's the modified duration. Okay, that's the M duration formula. M duration, it asks you what is the settlement date. So we're doing the sum as at 10th of May, maturity date, right? Coupon, yield. I'm just using the average yield. You can use the actual yield. Semi-annual basis and actual. Remember, we talked about the fact that the way bonds are calculated, it's based on actual basis. Denominator is actual, numerator is actual. Right. So this is the duration of the bond. The modified duration of the bond. Okay. Okay. So what do you see here? What do you see? Now, look at the maturity date. This matures 15th of June 24. Couple of days, right? Let's just put that also. Let's look at the number of days to maturity or the number of years to maturity. So this matures on 15th of June, minus we are right now on 10th of May, right? Divided by 365. We look at the number of years. Yeah. So this is the years to maturity. And this is the modified duration. Okay. What do you see? Do you see now this matures 15th of June, right? Duration is, we know that when interest rate, when life increases, duration increases. But do you see now this is 1 year to mature. Let's say this is like 1 year to mature, but duration here is 0.908, right? This is roughly 2 years to mature. Duration is 1.5. Now 1 year to mature, duration is very close to 1 year. Not 1 year, but very close to 1 year. 2 years to mature, duration is 1.5, right? 3 years to mature, duration is 2.4. These are the other bonds, so don't worry about that. What do you see? As you go along, 5 years to mature, duration is 3.6. Duration doesn't increase at the same rate as maturity, right? Just because, now, remember, duration gives you an idea of the sensitivity of the bond to interest rates. When interest rates are coming down, I want bonds that are very sensitive to interest rates, right? Because when interest rates are coming down, I want to get the maximum possible price gain. So if I buy something that very high duration, I can get a very good price gain. What does this tell me? When I buy a 5-year bond, right, this 4.98 5-year bond, right, when interest rates come down by 1%, my bond is going to go up by 3.6%. That's what it tells me. When interest rates come down by 1%, my bond will go up by 3.6%. I'm sorry, I think I'm running over time and you have another lecture. So we'll take this up next week. I'll show this again next week when we'll discuss it. I don't want it. So sorry about that. We'll stop at this point. Okay. Thank you.
Thank you, madam.
Thank you, madam.
Thank
Thank
you.
you.
Thank you, madam.
Thank you.